I'm very excited to be here in Stockholm, one of my favorite cities, and at this fantastic event. So, my name's Alex. The good news is I'm a services guy, so I understand the value of being on time. I will get you out to your coffee on time, or afternoon tea for my fellow Englishmen. Who here has heard of Hadoop? You all have, because the speaker from Vodafone earlier articulated it in very powerful ways that I'm not sure that I can match, but I'm going to give it a shot. Who has actually played around with it? Who's technical and has touched it? So maybe a quarter of the audience. Well, that's great. I was actually invited by my son's nursery class. My son's 3 years old, about 2 months ago, to describe what I do for work. It's incredibly hard to describe big data to a 3-year-old. I invite you on your way home, I challenge you, think about how you would explain what you do for work to a 3-year-old. And if you want to test it, I can lend you a 3-year-old to practice on. I'm going to start at the bottom of the stack and work my way up to the business value. It reminds me of the Einstein quote, if you can't explain something simply, you don't know it well enough. So let's see if I know it well enough. So I started by picking up my computer and said, kids, do you all know what this is? And of course, every self-respecting 3-year-old knows what a computer is. Most of them have been using computers since before they were able to speak, literally. And I said, well, here's a man called Doug who I work with. A long, long time ago, back in 2006, Doug had a problem. He wanted to do really, really big things with his computer, like take a picture of every star in the sky, write down the name of every star, and match it to the picture. And his computer wasn't big enough, so he had a problem. But then he had an idea. He figured out a way to connect lots and lots of small computers and create one gigantic computer. But he still had a problem. He didn't know what to call his gigantic computer. In walks his son to his office, carrying a yellow elephant. And he said, Daddy, my elephant is called Hadoop. And from then on, he decided to call his gigantic computer Hadoop. And that was the end of the story. And by the way, Doug actually calls it Hadoop. He's the only guy in the world who I think does that, but will respect the fact that he created it, so he can call it whatever he likes. So why does that matter? Why did that develop into more than just a very interesting computer science project? Well, first of all, well, actually, going back to the story, I then said, and Doug is such a nice guy, he decided to give this new technology away for free. One of the kids put up his hand and goes, why would he do that? Well, that's a separate discussion, which we can talk about later. But it is open source, which means that Cloudera, for example, will ship we have Cloudera Express, which is free. And any of our customers can use our free version if they want to. Any of you can use the free version if you want to. Or if you're really brave, you could even download the raw Apache version. It's also highly scalable. It is pretty much linearly scalable. We've tested up to the petabyte range and beyond. Our largest customers are running it on tens of thousands of nodes of servers. And finally, it's extremely flexible. As we've heard many times today, the world of data does not fit into very neat rows and columns anymore. Most data is being generated by sensors and by machines. It's in log files, and it's in various formats, audio, video, PDF, you name it. Hadoop is essentially, it is a way of making a cluster of ordinary computers appear to behave like one gigantic computer, resting on a file system that can ingest data of any type. And then you figure out what you want to do with that data on read. So that's why it's known as schema on read. So the original Hadoop paradigm, and just to give credit where credit is due, the original inspiration for Hadoop came out of Google. They published 2 white papers in 2003, which described a file system, which at the time was called Google File System, which is now known as HDFS, and then MapReduce, which was the original Java-based processing engine on top of that. It has developed into a very broad ecosystem. It's really an umbrella term for a large collection of open source Apache projects. Cloudera in our product, we ship something like 30 different components. And the flexibility also extends to the way that you process that data. SQL is great. I've spent many happy hours, days, and weeks myself writing SQL queries, but the world of data innovation extends way beyond SQL now. Going back to Hadoop's roots, obviously there is the need for Google-like search, and there is a Apache project called Solar, which we use to perform search on your data. Spark is a fairly new processing engine that can handle streaming data. So there are a number of different ways that you can manipulate your data and drive benefits from it. And the great thing about open source is, of course, the pace of innovation. If someone had said to me 2.5 years ago when I joined Cloudera that MapReduce would start to be sunset and replaced by another open source project as being the primary processing engine for your data, I would have said that's crazy. And then, of course, Spark came along. That's one of the projects that wasn't actually originated by us. We invest a huge amount in research and development into Hadoop. That came from a university, UC Berkeley. It was then first commercialized by another company called Databricks. We liked the look of it. We pulled it into Cloudera's ecosystem, and then we started to invest in the open source community and contributing our own code. And similarly, other projects like Kafka has come out of LinkedIn. The consumer technology companies, Google, LinkedIn, Yahoo, have all played a very large part in driving this ecosystem. So why does that matter, and why now? I think we can all agree by now at 2:45 in the afternoon that data is extremely abundant. I heard the Cloudera company founder speak last week, and he mentioned that by 2025, there will be 100 billion connected sensors in the world. 100 billion connected sensors in the world. I think that's conservative. That corresponds to, doing maths on stage, 14 or 15 sensors per person. I think it could obviously extend to way beyond that. Analytics is extremely pervasive. It's in your home. It's in your car. We do work with an American automotive manufacturer who's really seen as the pioneer in this new world of connected cars. Every car sends a stream of data back to a Hadoop cluster, which the customer can then do interesting things with, such as predictive maintenance, such as looking at how their customers are using new features which may have been downloaded the night before onto the car, if they're using them at all, and how they can be improved. And in my case, another sensor on my wrist, which is telling me that my heart rate is 80 beats per minute. Not bad for presenting. Computation is extremely affordable. We've already talked about some of the cost benefits. I like this quote from a technology historian called George Dyson, which you may have heard before. Big data is what happened when the cost of keeping information became less than the cost of throwing it away. The cost of keeping information became less than the cost of throwing it away. In other words, the value that you can derive from your data is greater than the cost of keeping it, and therefore there's no reason not to keep it. One of the most famous applications for this new data management and processing paradigm is the field of genomics. In 2001, it cost $100 million to sequence one genome. Any guesses what it costs today? Who said that? Here you go, have a free t-shirt. $99. And that can't be purely explained by Moore's law, which was described so eloquently by the speaker before me. Moore's law is, of course, that every 18 months, the number of transistors you can fit onto a chip will double, and therefore the processing power will correspondingly double. But that doesn't purely explain the improvement and cost efficiencies in processing something as hefty as a a human genome. It's also to do with the total computational throughput which can be achieved. And Hadoop can take a large part of the credit for some of the improvements in that field. So analytics is pervasive. It's extending to the masses. There's been an explosion of new data. There are new open architecture, open source frameworks for benefiting from it, and that is driving a new behavior in enterprises. This is another classic slide now that was shown earlier today, and it describes some of the most exciting new companies in Silicon Valley, and the common thread being, of course, that none of them hold any tangible assets, or not many tangible assets, whether it's cars or hotel rooms or media content. The problem with this slide is it suggests that only sexy Silicon Valley companies can actually benefit from big data, and that's clearly not the case. I do agree with, there was a good quote earlier this morning from Jack Welch. If the rate of change on the outside exceeds the rate of change on the inside, the end is near. And I completely agree with that, but that doesn't necessarily mean that the end has to be near. I think the challenge that most organizations see is that whereas the infrastructure is getting easier and easier to implement, we can get a production-grade, secure Cloudera Hadoop cluster up and running in hours, if not days. But then how do you then get business value out of it? Where do you next go on your journey? And I would invite you to say to your CEO, what are the top 5 questions you would like to get answered in order to drive competitive advantage? Does everyone agree that that's a fair question to ask your CEO? What are the top 5 questions you would like answered to gain competitive advantage? Then ask your CIO, what data sources do we have available to make that happen? And that's what our customers are doing. So we have banks who are asking, how do I identify in real time what my total risk exposure is? How do I report on regulatory compliance in a timely way so I don't get fined? We have banks saying, what does the profile of a consumer borrower look like? At the moment, we are cold calling everyone in our database, just going down the list alphabetically. How do I find someone who, I don't know, is just got a pay raise? We know that from his bank account. And he came to our website through the clickstream data. We know that he came from a car manufacturer. That, to me, would indicate somebody who might need a loan and who we should prioritize in our marketing campaigns. And here are some use cases of Cloudera customers where they are asking these kinds of questions. BT, not necessarily known as being one of the most exciting brands. They've been around for decades and decades. They were actually a government-owned company until the 1980s. They've been asking the question, how do we get better insight into our business customers? They had batch jobs running for 24 hours. They wanted to be able to get the relevant data in less than 90 minutes. They put all of their data in Hadoop. In so doing, they consolidated over 1,600 separate data silos. And now those jobs run in something like 90 minutes. Marks and Spencer's, another 130, 140-year-old company, if I remember correctly. They wanted to know what is the value of each customer? How do I know more about my customers? I want to be able to know what is their profile of spending online versus in stores? How do I get a complete customer 360? And also, which are the most effective sales channels for me? Within about a week of setting up their enterprise data hub, their Hadoop environment, they were able to identify that a lot of what they thought were their most profitable customers were actually, profitable partners, were actually people who were shopping on the Marks and Spencer's website and then Googling the item they wanted to buy online and then finding it cheaper through one of their partners. So just being able to look at that clickstream data was enabled them to really understand their whole partner ecosystem better and possibly agree better terms with those partners. Cerner is the leader in electronic medical records. This is a great one because this is one where Hadoop is actually used to save lives. Electronic medical records are often considered the kind of graveyard of technology. They're extremely difficult. They've managed to consolidate all these records into one enterprise data hub to give an end-to-end view of any single consumer any single patient's medical history, but then also to identify trends and, for example, spot incidents of sepsis in a hospital and manage to reduce the rate at which that happens. And then finally, market study, the most important, biggest insurance company you've never heard of. And when you think about when you buy car insurance, how many things do they ask about you? They ask your gender, your age, what you do for a living, where you live, maybe 5, 6, or 7 different parameters. What if you could look at hundreds of different data points on each individual and build up a better risk profile? So they were able to do that, and they were also able to reduce the amount of insurance fraud by £5 million. So I'll leave it at that. To summarize, by modernizing the data management architecture on Hadoop, our customers are able to get a better profile of their customers in 360. They're able to improve their security and manage their risk, and they're also able to build better data-driven products. Thank you very much.